These are the following problems that I'll be going over in this video. So if you'd like to skip ahead, please select the appropriate link now. Okay, whenever you want to factor a polynomial, the first thing you want to look for is the greatest common factor. Okay, so the greatest common factor is the largest thing that will divide all of them. Okay, so the first thing you do to determine the greatest common factor is you look at the constants, okay, or the number part. What is the largest number that divides 12, 36, and 30? So the way this works is whatever the smallest number is in the set, 12 in this case, it's got to be that number or smaller. Okay, so it helps to kind of think of what are the things that divide 12. So 12, 6, 2, 4, so forth. Of all those numbers, the largest one that will also divide this is 6. Okay, because 12 won't divide them, and then the next largest would be 6, and 6 does divide all three of them. Okay, so the hardest part of finding the GCF is actually trying to determine the constant on the GCF. The variables are actually a lot easier if they all contain a specific variable. For example, they all contain x's. Whatever the lowest exponent is, that's the exponent that'll be in your GCF. Okay, so if they all contain an x, then your GCF contains an x, and whatever the lowest exponent is, that's going to be the exponent in your GCF. So notice they all contain y's. Okay, so there's definitely a y in there. But now we just need to figure out what the exponent is. Whatever the exponent that is smallest is, that's going to be the exponent in our GCF. So the way factoring out a GCF works means that we can write it as 6xy to the 5th times some stuff. We can just rewrite this as 6xy to the 5th times some stuff. So we're trying to figure out, well, what stuff would go in here so that I could distribute this 6xy to the 5th and then get this thing. Now the way we're going to find that is we're going to take each one of these and divide them by 6xy to the 5th. So I'm going to do 12x to the 6th, y to the 9th, divide it by 6xy to the 5th, plus 36xy to the 10th, divide that by 6xy to the 10th, minus 30x to the 4th, y to the 5th, by 6xy to the 5th. Oops, sorry, I wrote to the 10th here. That should be a 5. Okay. Now this is a much more complicated way of writing it than you really need to. Usually the best thing to do is just kind of think about it. What I'm going to do is take each of these numbers and divide them by 6. That's what this is representing. Each of the constants will be divided by 6. And remember the exponent rule that says if you have a to the m over a to the n, that's a to the m minus n. So that's saying, since I have an x here and an x here, I'm going to subtract their exponents. Now, you'll never get, when you're factoring, as long as you picked your GCF correctly, you'll never get a negative exponent from this. Okay? So all we're going to do is go through each one of these terms, divide the number by 6, and subtract 1 from the exponent on the x's, and subtract a 5 from the exponent on the y's. So 12 divided by 6 is 2. X to the 6th divided by x is x to the 5th. I'm just subtracting 1 from the exponents. Then I'm going to subtract 5 from the exponent on the y's, so y to the 4th. So I don't recommend writing this step. This is really just to explain where the numbers are coming from. It's easiest just to look at it and say divide the number by 6. So it's 6, subtract 1x. Well, there's only 1x, so I won't have any x's left. Subtract 5 from the y exponent, so y to the 5th. Then 30 divided by 6 is 5, so negative 30 divided by 6 is negative 5. Subtract 1 from the exponent on the x, so x to the 3rd, and subtract a 5 from the exponent on the y, so that's a y to the 0, which just means there aren't any y's left. Okay, anything raised to the 0 power other than 0 is always equal to 1. Okay, so that means you don't have to write it. It's kind of, think of it as you're pulling these things out. You're going to take however many x's there were here, and you're going to pull out 1, so you're only left with 5. However many y's there are, you're going to pull out 5, so you're only left with 4 here. Here there were 5 y's. If you pull out 5 y's, there won't be any y's left. Okay, whenever you see a polynomial with 4 terms in it, you should always immediately try factoring by grouping. So 4 terms. Now, that doesn't mean that everything with 4 terms is factorable by grouping, but it's definitely something you should look into. Okay. Now, you should always check first for a greatest common factor. Well, if you look at these, there is no greatest common factor because not all of them are divisible by 5, not all of them contain a's, not all of them contain b's, not all of them contain c's. So there is no greatest common factor. So I'm going to want to factor this by grouping, or I'm going to try, because it has 4 terms. The way you factor by grouping is you split it down the middle, and you factor the first and the second piece separately. So you look for the greatest common factor in the first set, and then the greatest common factor in the second set. So the greatest common factor in the first set is an a, and the greatest common factor in the second set is a c. So do a times some stuff, so I just need to factor out the a from each of these, so it's just b plus 5. And then plus c. Now let's do the second part. I said I can factor out the c, so I've got that. If I factor out the c from that, I'm left with b plus 5. So all I've done is rewrite this piece here like this, and this piece here like this. Okay. Now the only way factoring by grouping will work is after you've factored each of the pieces if the things in the parentheses are the exact same. And in this case, they are. Excuse me. And in this case, they are. So what I'm going to do now is say, okay, well, a factor is just a thing that is being multiplied by something else. So this is a factor of that thing right there, of that piece. This is a factor, this is a factor. So they have this b plus 5 as a common factor, so I can factor it out. Now notice here, when I factored out this a, the stuff that went in the parentheses was the stuff that was left behind when I pulled the a out. Well, if I look at this whole thing here, if I pull the b plus 5 out from this whole thing, the second parentheses are going to be the 2 things that were left behind if I pull the b plus 5 out. So now it's completely factored. Okay, when you're trying to factor, the first thing you should always check for is greatest common factor. In this case, there isn't one. There is no greatest common factor among all those terms. So, because there are 4 terms, I'm going to see if I can maybe factor this by grouping. I do that by splitting it down the middle and factoring each piece separately. So the GCF of the first piece, since there's a 3 and a y in each, is 3y. And the GCF of the second piece is 5, because they both have a 5 in them. So that means I can write this as 3y times something plus 5 times something. Now for factoring by grouping to work, that something, the thing in the parentheses, needs to be the exact same. So let's see what happens when I factor that out. When I factor out a 3y, I'm going to get an x from the first term, and from the second one, I'm going to get a plus 1. If I do it in the second one, if I factor out a 5, I'm going to get an x plus 1. So, lo and behold, the 2 are the exact same. That's great. That means that I can factor out the x plus 1. And the stuff that goes in the second parentheses is always the stuff that gets left behind if you were to just cross these x plus 1's out. So 3y plus 5. Okay, the first thing you check for is greatest common factor. There is no greatest common factor among the first 4 among all 4 terms. So because there are 4, I'm going to check for factoring by grouping. Split it down the middle. GCF of the first 2 is x squared. GCF of the second 2 is 4. So that means I can make this x squared times some stuff plus 4 times some stuff. For this to work, these two things have to be the same, so let's see what happens. If I factor out an x squared, that's going to leave me with x plus 3. So the only way this is going to work is if when I factor this 4 out, that's also x plus 3, and lo and behold, it is x plus 3. So that means I can factor out the x plus 3, and the thing that's going to be multiplied by it is just the stuff that was in front of the x plus 3's. So x squared plus 4. Okay, when you're trying to factor, the first thing you should always check for is GCF. Is there something that'll divide both 2x squared and negative 8? And there is. 2x. Okay? Whatever the smallest number is if there's going to be a GCF, it's always that number or smaller. And if they both contain the same variable, it's always going to be the smallest exponent on that variable. So that means I can write it as 2x times some stuff, and I'm going to find that stuff by just dividing each of these terms by 2x. So I divide it by 2, so the 2's cancel out. X squared divided by x is just going to be x. Negative 8x divided by 2x is just minus 4. Okay? Now, don't think that you're done once you factor out a greatest common factor. That's usually a precursor to a more complicated type of factoring. So, whenever there are two terms, you always want to check for difference of two squares. You want to ask yourself, is this something squared minus something squared? Well, there is definitely a minus, and that is definitely something squared, but x is not something squared. So this is done. Okay. However, with the next one, it isn't going to be. If I factor out the 2, I'm left with x squared minus 4. Now I have what is known as a difference of two squares. Something squared minus something squared. The reason this is something squared is because it can be written as 2 squared. Okay? So whenever you have a difference of two squares, you write it as the first thing plus the second thing times the first thing minus the second thing. So this is 2 times, first thing is x. In this case, the second thing that we're referencing is the 2, the thing that needs to be squared. So plus 2, x minus 2. Okay, as soon as you see two terms, you want to ask yourself, is this a difference of two squares? So there's no greatest common factor, so we're going to go ahead and jump to that. There's a minus here, so odds are it might be a difference of two squares. So you ask yourself, can this be written as something squared? Can this be written as something squared? And it can, because this is the same thing as 2x squared, and this is the same thing as 3 squared. So that means I could write this, as this 2x plus 3 times 2x minus 3. Okay. If we try the next one, first thing you should check for is greatest common factor. There is a greatest common factor, it's x. If I factor out that, I'll get 4x minus 36. And now be careful with this one. It's trying to fool you. It's trying to make you think you can do difference of two squares, because 4 and 36 are definitely squares, or perfect squares, and there is a minus here, but this x would have to be squared for you to be able to do it. And since I factored the x out, I can't do this. Also, if you hadn't factored the x out first, this x would have had to have been squared for it to work, and it's not. So this is not a difference of two squares, so we are done here. Whenever you are trying to factor a trinomial, what you're trying to do is factor it so that it's a binomial times a binomial. Well, the way that foiling works, if we knew the answer and we were to FOIL it out, we would have two terms that add to give us 9x and multiply to give us 14. Okay, so what we're looking for are two numbers that multiply to give us 14 and add to give us 9. Well, those two numbers are 7 and 2, because 7 times 2 is 14, and 7 plus 2 is 9. So whenever you have that, if there's no number in front of the x squared, you can always follow this template where it's x plus the first number times x plus the second number. So it's just x plus 7 times x plus 2. Okay. Now, you do have to usually worry about signs as well, but when they're both positive like this, then these will both be positive. Okay, so we're looking for two numbers that multiply to give us negative 14 and add to give us positive 5. Now you have to be careful with signs when you have negatives in here. Okay, for two numbers to multiply to give us negative 14, one has to be negative and one has to be positive, because a negative times a positive is a negative. Now, the larger of the two is going to have to be the positive, and the smaller of the two is going to have to be the negative, and that is because when we add them up, we need to get something positive. Okay, so we're going to have to put the positive on the larger number, well, the number with the larger absolute value, and the negative on the smaller one. And that's always going to be true whenever you have a plus minus like this. Okay, so I'm looking for two numbers that multiply to give me negative 14 and add to give me 5. So that would be positive 7 and negative 2, because 7 minus 2 does in fact equal 15. So then you just use the template, x plus the first one times x plus the second one. So x plus 7. In this case, the second one is negative, so when we do x plus negative 2, that's just x minus 2. Okay, as soon as you see a number in front of your x squared, you should definitely check for a greatest common factor. So in this case, there is 3. So I can factor it as x squared plus 3x minus 10. Okay. So now what I'm looking for are two numbers that multiply to give me negative 10 and add to give me 3. Now I'm going to have to just because I factored out this greatest common factor doesn't mean that I'm done. I still have this trinomial here. When you see a trinomial, I need to still check and see if it'll factor. So because this one's negative and this one's positive, if we can find two numbers, we're going to need to put the negative on the smaller of the two factors. So sometimes you may have to test it out, see what happens. Negative 10 times negative 1 does definitely multiply to negative 10, but when we add them, we just get 9. So that one doesn't work. The next one would be negative 2 times positive 5, and if we do negative 2 plus 5, yes, that does in fact add to 3. So that's the ones that we need. Okay, so that means I can do 3 times x plus the first number, which in this case is negative 2, so it's minus 2, and x plus the second number, which is 5.